Alright, this is a video for how to find the rule of an arithmetic series. You can use this to help you find the rule that you're looking for in the platform problem, the final part, the third and final part of the platform problem where you're finding the fabric. So this is a continuation of the last video that we had. So you should see on the screen that we have essentially what we had last time minus a little bit of work. And we're going to do the 100th term again and then use what we did to help us find the sum of the first n terms. So we don't need to find the 100th term because we already had it from before, but I do want to find the sum of the first 100 terms again. So here we go. So to find the sum of the first 100 terms, we have to add the first and the second and the third, etc., just like all the others. If you haven't watched the previous video, you need to before watching this one, or else this is going to be really confusing. So stop the video and watch the other one back on the YouTube channel or the last Juno homework. So we need to add up 4 plus 9 plus 14, etc., all the way up to the last term. But what's the last term? It's the 100th term, which we found before was 4 plus 5 times 99, which if we do the math, 5 times 100 would be 500, but this is 5 less than that, but then we add 4, so we get 499. So the last term that is included in our series here is 499. That's a little squishy, so I'll rewrite it. And so we are looking for 4 plus 9 plus 14, keep going. And our last number, once again, is 499 because that is the 100th term, or you can think of it as the height of the 100th platform, if this were a platform problem. And the one that comes before that, of course, is 494 because in the sequence, the common difference is 5. You don't have to do that part, but just to help you see that the pairs indeed do add up to the same amount. So we pair up the first and last, add them together, we get 4 plus 499 is 503. We can do that to the next ones in. 9 plus 494 is also 503, and we know that we could keep on doing that all the way to the middle, and they would always equal 503 as long as we're pairing in this way, because it's an arithmetic sequence that we're looking at. So we know we have a bunch of 503s that we're adding together. If we knew how many, we could easily find the answer without having to actually add up 503 a bunch of times just by using multiplication. So we know the value of each term is 503. I'm sorry, not the value of each term, the value of each pair. The value of each pair is 503. So if we knew how many pairs we had, that would be how many 503s we had, and therefore we could find our answer. Right? We just multiply 503, which is the value of each pair, times the number of pairs. Well, how many pairs do we have here? We're thinking. Well, here there are 50 pairs. Why? Well, there were 100 numbers in the term, there were 100 numbers in the series, but we paired them up, so there are 50 pairs. And 503 times 50 is 2,515. Is that right? No, that's just 25,150. That's what 503 times 50 is. So 25,150. But we want to know what the sum of the first n terms are. Right? We want to be able to find so we need to add together 4 plus 9 plus 14 plus ... plus what? What's the last term? When do we stop? Well, if you remember, when we're adding up the first 100 terms, we stopped at the value of the 100th term, which was 499. That was a sub 100. So for this one here, instead of a sub 100, we're going to have a sub n. Well, what's a sub n? Luckily for us, we already found that. Right? We have the direct rule for the sequence. We know what a sub n is. Right there. 4 plus 5 times n minus 1. We have the direct rule right below that blue mark too. A sub n equals 4 plus 5 times n minus 1. So that is what a sub n is. Confusing, I know. We don't like that. We don't like having such a long expression for a term, but that's what it is. It's 4 plus 5 times n minus 1. So we can go ahead and pair these up. Right? And that's going to be, the first term is 4, plus the last term is 4 plus 5 times n minus 1. Let's look again where that came from. Right? The first term was 4. The last term was 4 plus 5 times n minus 1. Right there. So we just did the same thing that we did up there with the 100th term. Right? We did the first term, which was 4, and the last term, which was 499. And we added them together, and we got a nice number, 503. Here we're not getting a nice number. We're getting 4 plus 5 times n minus 1. But that's okay. Right? And if we kept doing that, we kept pairing up. We know it's an arithmetic series, so each pair would continue to be 4 plus 5 times n minus 1. All the pairs, each pair would be 4 plus 5 times n minus 1. The value of each pair, once again, is 4 plus 5 times n minus 1. We don't like that. It looks ugly, but that's what it is. We can simplify it a little bit. We could simplify it all the way. I'm going to go ahead and add the two 4's together. 4 plus 4 is 8. That leaves me with 8 plus 5 times n minus 1. We could simplify further, but we don't have to. We can just leave it as is. 8 plus 5 times n minus 1. So now all we need to do is know the number of pairs. We already have the value of each pair. Now we need to know the number of pairs. If we knew how many pairs there were, how many times we have 8 plus 5 times n minus 1, we could get our answer. Up here we had 50 pairs because there were 100 numbers. We paired them up. So we have half of 100, or 100 divided by 2, which is 50 pairs, because we paired all 100 numbers up. So we have 50 503s. That was for a sub 100. We don't have a sub 100, we have a sub n. So instead of taking half of 100, because there are 100 numbers, we instead have n numbers. So we need to take half of n, or n divided by 2. That's how you find half of something, just divide it by 2. So if there are n numbers, there are n divided by 2 pairs. So now we know the value of each pair is 8 plus 5 times n minus 1, and we know we have n over 2, or n divided by 2 pairs. So just like before, when we multiplied 503 times 50, We just have to multiply the value of each pair times the number of pairs, and we have our answer. 8 plus 5 times n minus 1, that's the value of each pair, times the number of pairs, which is n divided by 2, or n over 2. And that should get us our sum. That should get us our sum of any number of terms. It should work. That's our rule. We hope that it's right. Luckily for us, like most things in algebra, oh, woohoo, we can check it. Make sure it's right. There's no reason to have a wrong answer because we can make sure we have the right answer. Yes, it was a lot of work to get this far, but so what? Why would you want to do all that work and have a wrong answer? How about if we do lots of work and get a right answer? So let's check the sum of the first 4 terms. Let's use our new rule or formula and plug in 4 for n. So we have 8 plus 5 times n minus 1, but instead of n minus 1, I'm going to write 4 minus 1 because we are looking for the first 4 terms. Times, instead of n over 2, I'm going to write 4 over 2 because n is 4. And we can go ahead and do the math. 8 plus 5 times 3, because 4 minus 1 is 3. We do parentheses first. And we can go ahead and do the other parentheses. 4 divided by 2 is 2. That makes sense. We have 2 pairs when we had 4 numbers. 8 plus 5 times 3 is 15. All of that times 2. We still have to do parentheses first. Remember our orders of operations. 8 plus 15 is 23, so we have 23 times 2, which is 46. Is that right? Is that what we wanted? Let's go back up. We already found the sum of the first 4 terms. Keep going up. And there it is. When n is 4, the sum was 46. Look, you can see it right there. So 46 checks out. So it looks like our rule works. Big check mark. Yay. Woohoo. There it is. That's our rule. Stars are shining brightly. Many stars. We have fireworks going off because we're so excited that we did all this work and we got the right answer. Yay, us. I'll even draw some balloons in here because we can have a party, and you can't have a party without balloons. So congratulations. Watch this over and over again till you get it.